Hi, let's do some calculus. So today we're going to pull in a lot of what you already know about particle motion, but now it's just time to practice this. So follow along as needed, but the more you can do on your own and then check, the better. And I think the more that you'll understand this. So the velocity of a particle is given by this function. V of t is equal to 3t plus 6, and the position at t equals 2 is 3. As soon as I see this, I like to write down position at 2 equals 3. And I know I'm given velocity. Okay, now I've got to just figure out what each one of these things mean and take from all the things that I've learned so far, even just this year, about particle motion. So the first question said, is the particle moving to the left or the right at t equals 2? Well, I know a particle moves to the left when velocity is negative and to the right when the velocity is positive. So what I need to know is, what is the velocity at 2? 3 times 2 plus 6 would be 6 plus 6, also known as 12. And this one, it's really crazy, but we don't have any units. V of 2 is greater than 0. I'm justifying. Therefore, and I'm answering my question, the particle is moving right, or to the right, at t equals 2. Done with A. Part B, what is the position of the particle s of t for any time t is greater than or equal to 0? So I should have said in here, since this apparently says s of t, there we go, s of 2 is equal to 3. They're saying the position function is s. So for part B, if I want position, but all I'm given is velocity, then I must integrate. So I'm going to say the integral from, this says what is the position for any time. Ooh, okay, so this is a little bit trickier. This is for any time. So I'm still thinking of integrating, but if I know velocity was 3t plus 6, that means position is the antiderivative, or I can say 3/2 t squared plus 6t plus c. And if I want any time, and really you could have integrated this, also you could have done, like, because this is what I was going to do, if it was any time, you would have to say from 0, or in this case from 2 to t, and then had p of t minus p of 2 over here, and then solve for p of t. This would have been the same thing. So if you were like, no, I went with this way, that's okay. But I did this now. I've got s of t. Oh man, I said p again. There we go. Why am I writing in pen? So it's easier for you to see, but I don't usually like to live dangerously, and this is why. This is 2 to t of v of t to t is equal to s of t minus s of 2. And I could do it this way. I could take the antiderivative of this business and then add 3 to both sides, because that's what s of 2 is. Or I could say, well, I know s of t is this, and I know s of 2 is 3. So put in 3 for s of t, 2 for t, and solved it this way. 4 divided by 2 is 2, times 3 is 6. 6 plus 12 is 18. 3 minus 18 would be negative 15. It's equal to c. So you would get s of t is equal to 3t squared plus 6t minus 15. If you did it this way, you still should have gotten the same thing, because you would have integrated over here, and then you would have evaluated from 2 to t, would have gotten the same answer. Okay, we did B. Oh, sorry. And part C, does the particle ever change directions? So remember, changing directions means that velocity would change signs. If velocity is positive, the particle is moving to the right, negative, moving to the left. So I need to see velocity, which is 3t plus 6. I need to see, is there ever a time where it's changing sign, meaning going from positive to negative or negative to positive? So I'm setting velocity equal to 0. Divide by 3. At time t equals negative 2, the particle could possibly change directions because velocity is 0. In this one, does it say anything about the particle being time greater than 0? So you could say the particle changes directions at time t equaled -2. Most of the time you'll be given something like this, where time is greater than or equal to 0, just because it doesn't make sense for a particle, for time to be negative. So I'm going to say particle never changes directions when t is greater than or equal to 0, as v of t never changes signs when t is greater than or equal to 0. Boom, moving right along. Let's do one more. Part D, find the total distance traveled. Remember, total distance would be the absolute value of velocity from the interval from 1 to 4. But we already know that this particle doesn't change directions when the velocity is, or when t is greater than or equal to 0. We just solved that in C. So right here, all we have to do is integrate from 1 to 4, because in this case, they will be equal to this. So v of t never changes signs when t is greater than or equal to 0. And so these are now equal in this problem. So what I can do is I'm going to integrate from 1 to 4. This is 3t plus 6. Take the antiderivative. Oh, I don't even need a plus c because I'm just integrating from 1 to 4. Substitute in 4, substitute in 1, subtract them. So I've got 3/2. 4 squared is 16, plus 6 times 4 is 24. Substitute in 1, you'll get 3/2 plus 6. 16 divided by 2 is 8. Then I would have times 3 is 24. 24 plus 24 is 48, minus 3/2 plus 6 would be the same thing as this would be 12 over 2. So this is 15 over 2. Oh man, by the way, you could leave your answer like this. Actually, you could actually leave your answer like this and just circle the whole thing. Anything that you can put in a scientific calculator on the AP exam is fine. But if I just keep going with this, actually, I might even change this. 48 minus, and I know this is like 7.5. 48 minus 7 would be 41, minus a half would be 40.5. But if you wrote it as a fraction, that would be just fine too. Okay. Let's do another one. Acceleration of the particle. Okay, so we have a free response. Let's go into a multiple choice. Acceleration of the particle moving along the x-axis is given by this function. I've got a of t. If the velocity is 25 when t equals 3, so I know v of 3 equals 25. And the position is 10 when t equals 1. Ooh, this looks fun. Then the position, x of t, x of t doesn't really matter because these are all multiple choice, so I can call whatever I want. So I'm just going to say x of t is equal to p of t, so I can just stick with p's, but whatever. If I know acceleration is 6t minus 2, you can do this multiple ways. You could go backwards and you can integrate acceleration and set it equal to v of, in this case, v of 3 to v of t, and then figure out what v is. I'm just going to go backwards this way, and I'm going to say, well, v of t then would have to be 3t squared minus 2t plus c. And I know the velocity of 3 is 25. This would be 27 minus 6. 25 is equal to 21 plus c. So 4 would have to be equal to c, but that's, remember, that's only for velocity. So we're not quite there yet. I've got 3t squared minus 2t plus 4. If I want to get back to position, you can say p of t or x of t because that's what was given. Add 1 to my exponent, divide by my new exponent. Don't forget plus c. And you could start eliminating things right now because you know this is going to be t cubed minus t squared plus 4t. So I think there might only be one answer right now. Yeah. That's in that form. But if you want to be really sure, you can say p of 1 is 10. 1 minus 1 plus, does that say 4t? So plus 4 plus c. This would be 0. 10 is equal to 4 plus c. 6 is equal to c. Hey, we got it anyway. Okay, another one? Is that what you asked? Did you say, I really wish I could try one of these on my own? Okay, so that's what you're going to do. You're going to use this as needed, but you can see that these ones are super similar to the ones on the first page. Well, kind of. And so use that as a guide. And also, this is a different problem, so it won't be exactly the same. So a particle moves along this x-axis so that its acceleration, ooh, so different than before, because before we had velocity. At time t equals 0, the velocity of the particle is -9, its position is -27. So I know velocity, velocity at 0 is -9. The position at 0 is -27. So I know some stuff. This one says, find v of t, the velocity at any time t. Because I did the first one the one way, do I want to do it this way again? Doesn't matter. But if acceleration is 6t plus 6, velocity is the antiderivative, so add 1 to the exponent, divide by my new exponent. But don't forget that plus c. And again, you could have integrated acceleration and got back to velocity, and you could have done this from 0 to t, and then you would have had to substitute in t, and then substitute in 0 and subtract. If you're like, I don't know what you're talking about, just stick with me here. So I've got velocity. I know the velocity of 0 is -9. 0 is nice because this would be 0 plus 0 plus c. That means velocity at any time t. Okay, check yours. Did you get velocity? Let's go on to B. We did A. B is for what values for t is greater than or equal to 0. There it is the particle moving to the right. So I need to figure out where does the particle change positions. Is there any time when t is greater than 0? I know velocity is 3t squared plus 6t minus 9 because we got A. If I set this equal to 0, oh, that was super weird. I looked at the wrong paper and was like, oh no, am I going off in the wrong direction? No, I'm fine. If I factor out a 3, I'll get 2t minus 3. You can divide both sides by 3 and then it just goes away, so I get 0. And then if I factor this side, I would get t plus 3, t minus 1. Because that'd be t squared minus t plus 3t minus 3. Yeah, we're good. So position, or the velocity, I should say, changes signs potentially at t equals -3, which I don't care about that one because it's under 0, and at time t equals 1. I do care about this one. So what I'm going to do, oh, it's like going back to an old friend, guys. So I want to make a chart from 0 to 1, and I know at 1, velocity is 0, and then 1 to infinity. Going back up to velocity, I'm going to actually do this one. If this was 3 still, 3 times this, because this is positive, and I can just figure out if these are positive or negative. From 0 to 1, let's say a half. A half plus 3 is going to be positive. A half minus 1 is negative. Positive times negative would be negative. I know the particle is moving to the left from 0 to 1. From 1 to infinity, I'm going to say, let's pick my favorite number, 212. 212 plus 3 is positive. 212 minus 1 is still positive. Positive, positive, positive is positive. Now I can answer my question. Particle is moving to the right when t is greater than or equal to 1, so that'd be 1 to infinity, And my justification is as v of t is greater than 0. We did it. We justified. We said when it was moving to the right. We justified. Boom. Part C, find the net distance. Okay, net distance, remember, is going to be p of b minus p of a, or I can say the integral of v of t. And I want on this interval from 0 to 2. Net distance, so 0 to 2. And then what I'm going to do is I'm going to say, okay, 0 to 2. I don't have to do anything with absolute value in here. 0 to 2 of v of t was this whole thing, 3t squared plus 6t minus 9. Add 1 to my exponent. This would be t squared. We did this a lot already, and I should have done this one. Minus 9t, and I'm going to evaluate from 0 to 2. If I substitute in, and I put 2 cubed is 8, plus 2 squared is 4 times 3 is 12, minus 18. That would be like my function value at 2. Substitute in 0. 0 plus 0 minus 0 is 0. My change in position would be 8 plus 12 is 20, minus 18 is 2. 2 what? I don't know, because no units were given to me. 2 units of some sort. Okay, last one, if I did D. Find the total distance traveled on this interval from 0 to 2. So the total distance traveled on this interval from 0 to 2. And I'm going to think, okay, total distance is the absolute value of v of t dt from 0 to 2. But I know this particle changes directions at time t equals 1. So what I do here is I break this integral up from 0 to 1, v of t dt. And whatever I get here, even though I'm moving to the left, I'm going to take the absolute value of that answer, the entire thing. And then I'm going to go from 1 to 0, or I'm sorry, 1 to, what are we going to? 2? And you can also make this one the absolute value just in case you messed up your signs here. Or you can say, oh, well, I already know this is going to be positive because I'm moving to the right. Whatever. Okay, 0 to 1. This is the same thing we would do up here. We're just going to say t cubed plus 3t squared minus 9t. Evaluate from 0 to 1, but I have to make sure to make this positive. So if I get my answer here, I'm going to get 1 plus 3 minus 9 minus 0 plus 0 plus 0, or minus 0. I have to make whatever I get here, even though this is going to be a negative because it's going to be 4 minus 9, which is negative 5. I have to actually make this positive 5. If I integrate, oops, sorry, I don't need to write this integral symbol anymore. T cubed plus 3t squared minus 9t. But I do it from 1 to 2. This should be positive because I was moving to the right. 2 cubed is 8. Plus, this would be 2 squared is 4 times 3 is 12. Minus 18. It's like my f of 2 minus f of 1. 1 plus 3 minus 9. This is where I've got to make sure I don't mess up anything. Ooh, and I'm totally going into this space. This would be positive 5 plus. This is 20 minus 18, which is 2 minus 1 plus 3 is 4, minus 9 is negative 5, but this is minus a negative 5, so plus 5. 7 plus 5 is 12 units. And it makes sense, my total distance, oh, totally just wrote over where my face is. 12 units, your total distance should always be more than or equal to your net distance. Okay, one more problem. A particle moves along the x-axis so that its velocity is given by this function. On the interval from 0 to 10, how many times does a particle change direction? This one is a calculator problem, and so if you are given velocity, Well, knowing it's a calculator problem, you should try this. Remember, a particle changes direction when velocity changes signs. So if I go into y equals, and I've got, the hardest part of this is just actually putting this in, what this is. So this would be cosine of x, but then you square the whole thing, divided by x minus 1/5. I need to make sure that my window, I can see from 0 to 10. So I'm going 0 to 10. And I might have to change these y mins and y maxes to be like -1 to 1, because I'm going to guess it's going to be kind of squished. But yeah, see how it's a little bit hard to see here? So I want to get just closer. So I'm going to go from -1 to 1, just so it's easier to see when I change signs. Oh, there we go. And I might even need to go in a little bit further here, but it looks like I changed signs. 1, 2, 3, not here. So far I'm thinking 3, but I'm going to zoom in on that part just to make sure I don't change signs. So I'm going to do zoom and then box. And if I go up here, you see how there's a little cursor? If I push enter, I'm going to zoom in on this area just to make sure I didn't change signs and then I just couldn't see it. Nope. So I'm good. So I can see that I went from, oh, I'm sorry, 0 to 10, -1 to 1. I can see that this particle changes direction 3 times because the particle, the velocity changes signs 1, 2, 3 places. And this is sad, but I think I'm actually going to hold off on page 210 again and just make it its own thing. So thanks so much. Have a great day. Thanks for learning. Thanks for working. I appreciate you. Bye.